This is a short introduction to Stellarium, the free open source planetarium application. And this is the website. The latest version is 23.4. And you have the options for different operating system, Linux, Mac OS, and Windows. There's also a Stellarium web version in which you can work directly online without downloading any app. However, the web version is not really good, so do not use it. Okay, it's not good enough for our lab. And to remind you, in case you do not have PC of your own that you can work with, lab PCs in the physics and astronomy department have Stellarium. Okay. In addition, the first lab, Stellarium Starter, is designed for you to become familiar with the basics of Stellarium. It will ask you more questions than what we're going to cover here. In this video is really just a minimal introduction. And so let's launch Stellarium. And you see right away that it occupies the entire screen, making it inconvenient. So what you want to do is you want to minimize it so you can work with other application on your computer. So move your pointer down so that the menu pops up. Go to this control called full screen mode, click on it, and the screen will minimize. I reshape it towards a point which I can see the view sufficiently well. And immediately you can see that this is simulating what you will see in real life, right? There's a ground, right? And then there are trees and other objects, maybe buildings, and the evening sky. As of now, the time is 5 a.m. in the morning, okay? And let's see, let's do some basic control. Just to show you, if you move the pointer towards the left-hand side, this control setting menu shows up. If you move it towards the bottom, the operational menu shows up, okay? So we'll go through some of these. And we already gone through this. Okay, so you can drag the view, okay? This is a screen recording, so it does not show what my hand is doing. But basically, I'm using the touch pad to zoom in and out, as well as dragging the screen into what we call a sky center view. I can also drag it in a way in which it becomes a ground center view. The sky is around rather than in the center. But for this course, also in reality, we will be primarily using this what we call sky center view. If you think about it, star charts a star chart would look like this. Okay. Another thing that we can do, in fact, we just did, right? So let's click on a star. Oops. Any star, Capella. For example, it says a double star, Vega, right? Type is a double star, pulsating variable star. So this is actually a giant, what we call a giant star, pulsating variable star. And it shows you the magnitude and other information and distance, which these are the information that we'll be using throughout the lab, throughout the semester in various labs, okay? Okay, let's go to the setting menu. By the way, as you can see, I'm randomly clicking, and yet, no matter what I do, I easily hit a star. Okay, now I succeeded in hitting a spot in which no star, and that's good because I want to bring out this menu to show you. Location window, and you can see there's also a number associated with this, and that's, you can see on the screen, is F6. So each function in the Stellarium, you can also use a corresponding key on your keyboard if you know what to do. But I don't bother. I just use this function on the screen, okay, using these menus and using this control button. Now, the first thing about the location window is that it shows you where you are. and you have to make sure that's exactly where you want to be. You can, of course, you want to be in Miami. Let me go to, say, Miami, and select Miami, and you will see the red arrows shows you that's where you are. And of course, you see, if you pay attention, you see that the background has changed. Of course, the sky in Rockville and the sky in Miami will look different at the same time, right? We're a different location on Earth. But in order to go back to where we are, okay, to go back to exactly where we are, where I am, play around with this tool button right here, right? Get location from network. Use current location as default. Okay, just play around. And then you see that the red arrow points back towards Rockville, Maryland, with the correct latitude and longitude. Now, just in case you want to go somewhere exotic and the name is not given or anything like that, some unknown place in the ocean, right? You can actually specify the latitude by typing it in directly right here. That's another way. So there are various ways that you can find it. But the most important thing is to make sure to know where you are as pointed toward by the red arrow. Okay, next one, daytime window, self-explanatory. So right now it's 5 o'clock. So we have year, month, date, and then hour, minute, and second. So let's go as we increase the time, right? You see the sun is rising and so on. And this is a realistic view of what's going on here, okay? Setting. Now we want to demonstrate some effects. Now we're jumping ahead a little bit, and to show you the reason that we can see in Stellarium this realistic simulation of what we actually see, right? We actually see it this for real. It's because we have this control called ground and atmosphere. Now, once I turn off atmosphere, surprisingly, or maybe not, we see a dark background and we can see the stars. So the reason that we actually see the sky as blue is because the atmosphere scatters the sunlight and makes our view of the sky bright and blue. Okay, make sure you understand that. It's one of the basic things in science, but people actually don't know that very well. But if we do not have this atmosphere, let's say we're on the moon, or we actually go outside of this atmosphere, let's say we take a space shuttle or to the International Space Station, we actually will see, without the atmosphere interfering with our view, we actually see the background like this, okay? Right, so just keep that in mind. Now with the atmosphere off, we can also turn off the ground. It's another one of these magical tricks in Stellarium. You can actually see what objects are there below horizon, below ground, okay? So it's very nice. You can do certain things. So let me turn this back on. So let me go back to 5 o'clock. All right, so day and time. Okay, so now next is sky and viewing option. Oops. Click on a random place and this information shows up. It blocks the view, but that's okay. Let's not waste time. Let me just go to, look. Sky and viewing options window. The first thing I want to do directly is actually go to landscape first and show you this ocean choice as the background. Okay, so maybe for this option, what I want to do is go to a daytime mode so that you can see what the choices of things, right? These are things. So the ocean thing shows you a picture of the ocean with a very flat horizon. You can also choose zero horizon just for a bland, boring, displays of the ground showing a flat horizon. But I just don't bother with it. I like to look at the ocean, fantasizing myself on a cruise line, looking out in the ocean, looking out to the beautiful view. And if it's in the evening, right? If it's in the dark, like in the morning, then you can see the evening sky, right? And so on. All right. So landscape. Let's stick with ocean theme. So sky. Let's go to the sky option. These are different choices that you can make and how you want to see the sky. But I just want to point out the limit magnitude of 6.5. This is really the limit of the brightness of the object you want to see. Our human eyes can see up to about 6.5. So the 6.5 choices that we have here mimics what we will see realistically in the evening sky. So let me go back again towards the evening. So this in Rockville on 5 o'clock in the morning, if you go out on a clear day, this is basically what you are expected to see. Okay, you can see more by changing these limit magnitude, but the limit magnitude of 6.5 is a realistic number for what we can actually see. Okay, so next one is the solar sky object, and really kind of boring. We don't work with this too much. The next one is the deep sky objects, and you can select all, which we're not going to do, or select the standard set, which is the Messier catalog, the NGC catalog, and the IC catalog. Okay, so this is a standard set. Okay, so these are the objects in which will be shown, will be available in Stellarium. I mean, there's already a lot more, but we don't need to do that. Markings is a very important a set of choices that you can work with. We can have equatorial grid and the azimuthal grid. But I want to point out the equatorial grid, because they are very important, they are also available here as a function button directly on the menu. You don't have to use it here, okay? So I won't bother with that right now. And I just point out the one that would be interesting would be equator, ecliptic, and maybe the horizon, and I explain that later on. Now, equator is a celestial equator, and what I want to point out more interestingly is the ecliptic. Let me see if I can demonstrate the interesting features about the ecliptic. Let me turn off the ground, right, and show you, okay, the ecliptic, right? Look at this. Jupiter, Saturn, Sun, Mars, Mercury, Venus, and so on, all along the ecliptic. Okay, the moon is kind of, not exactly on the ecliptic, but nevertheless it will move around it. Okay, so ecliptic is roughly by definition where our solar system objects will move around. Okay, that's sort of the rough definition. For a good reason, you will learn why later on. Okay, and you can thicken the line just in case your visions, your eyesight are not very good, right? You can thicken the lines. The partition, you don't need that, but you can turn on the partition here and so on. You see, and also the label, right? Where the marking on these ecliptics, equators, and all other lines. You can make your choices. So you are going to go through some of these in the lab. I think we have already gone through the landscape. That's correct. Let's go to sky culture. Now, this is one of the most important things that you need to learn, because it is not available on the menu, on the in the bottom menu, these operational button, right? You have to do it here. So to demonstrate, let me show you the most important one, modern IAU. Of course, there are other sort of the mythology that is explained in different cultures and so on. And for some reasons I don't understand, modern IAU is listed here. This is the modern definition as set by the International Astronomical Union. So in my view, it's actually scientific definition, and it shouldn't be under sky culture. But strangely, it's here. But it's okay. It's available. So just make sure you stick with modern IAU, unless you are interested in, let's say you are a history major, humanity major, you are interested in other mythologies or other cultures' view of the sky, right? But we're doing science here. We're gonna stick with International Astronomical Union's definition of the sky. And to demonstrate, show label, constellation line, and show boundary. State again, you have to come here. There's no choices. There are no function to pick here. You have to come in here. And you see right away the background shows this picture, okay? So to make it even more, to make the illustration better, let me thicken the boundary line for good purpose, okay? I want to show you. Now I want to find quickly the Orion or other well-known constellation as an example. Okay, one of the things that you can do, demonstrate at the same time, is that you can use search window and let me look for Betelgeuse. Okay, it must well. There you go. See, it found Betelgeuse. So I also demonstrated how you use the search window. The reason I was searching for Betelgeuse is because I want to look for the Orion constellation. I know Betelgeuse is one of the arm or the shoulder stars of Orion constellation. But let me be careful with the word constellation. When I use the word constellation, most of you will think of this shape that looks like this hunter or this warrior, right? But the modern definition, and I'll repeat it and I'll say just once, and you have to get this. The modern definition of constellation is actually a spatial region in the sky, and with a well-defined boundary. So a constellation, by modern science definition, is a region. It's not a group of stars that makes up, that looks like something. Okay, make sure you understand this. It's a region. Now, why is this important? Well, it's like a map. Think United States, with all the states with clear borders, and every building, every person, every object, every landmark belongs to a certain state, right? Because the borders are clearly marked. Same thing with the constellation. It's a map of the sky, with defined boundaries, separating the skies, the sphere, the spherical view of the sky, into 88, repeat, 88 regions. Okay, so, and these regions are called constellation. Of course, the modern definition respects the mythology and the typical astrology, right? And just divide up the region according to what people are familiar with, such as Orion, Gemini, and so on, right? I mean, we could divide the sky according, in any random fashion, but you just choose the sort of the common and convenient as what's perceived by the common culture, right? And so this is the constellation Orion. Okay, now I want to point out something. Understanding this boundary is important to do accurate science in terms of labels and markings. Okay, suppose I found a star here. Let me randomly click on the star. Oh, there you go. I found it, and it's called 134 Tau. 134 Tau. All right. Now, if I ask you, in what constellation is 134 Tau? If you just look at it without this boundary, okay, without the understanding of the constellation, you will say, oh, look at it. 134 Tau is in Orion. You would say that, right? Because it's very close to Orion. But no, if you look at carefully, right? Just look at 134 Tau is actually within the boundary of Taurus. So 134 Tau belongs to the Taurus constellation, not Orion, right? And of course, the name gives it away, right? 134 Tau, because is considered the number 134 largest stars of Tau. That's the way we think about it, okay? So make sure you understand this this aspect about the constellation and the boundary, okay? So let me turn it off. And let's see, anything else? Yes. One last thing, let's go back to markings, okay? So there are two more things to show you. One of them is horizon. Right, one of them is horizon. Let's say you have turned off, you are in the magical mode, you'll turn off the ground, so the ground is not there. But you still need to know where the horizon is to have an understanding of where that horizon line, where you're looking at the sky and so on. But without the landscape, remember you have turned off the land, right? You have turned off the ground, right? So the landscape is not being shown. So in order for you to show the horizon line, you have to come here and show horizon. And let's see if we can find it. There you go, see? The horizon shows up. So this green line shows you that you're actually, the ground is right here. You're actually looking towards north this way, and the sky is here, okay? But of course, the ground is turned off, so you can actually see below ground. In addition, you can also select colors. Okay? We won't go into that, I think it's pretty obvious. Okay, anything else? Cardinal point, right, the second thing. Here we also have cardinal points, and of course, cardinal points are the directions, news, N-E-W-S, north, east, west, and south, right? Basically, let me start out with, there you go. Let me start out with this. Let me start out with a sky center view. Marking. So if you just select cardinal points, you show the 4 major points, right? The 4 major directions. But you can select 8 to show the middle one, southwest, northwest, northeast, and southeast. You can also show the 16 partitions and the 32, right? So you can choose this. Typically, we leave it on 8, right? So you get a better idea of where things are. Okay, but 16 and 32 is probably too much. Okay, let's see. Let's go to the bottom menu, and these are basically the shortcuts to many of the functions here. Everything that's shown on the bottom menu, there are just shortcuts to whatever these options have. And so because we use them commonly, so these shortcuts are convenient. Okay, so let's just go through some of them. Right, the time. You can play with time here. You have play, fast forward, and fast backward. This is the partial or the full screen mode. And this is ground. This is ground. This is ground right here. And atmosphere right here. Okay. Okay, now the two final things to show are the equatorial grid and the horizontal grid. Okay, and now the horizontal grid is also called the azimuthal grid. Now remember, let us turn on the ground. Let's go back to the ground view. Just want me to take a little explanation. Okay, so we're now back into a horizontal view, okay? But now we're gonna turn on the horizontal grid or the azimuthal grid, which is a local coordinate that you set up wherever you are. So wherever you are, let's say you're in Rockville or Singapore or Tokyo or London, wherever you are always gonna set up your own coordinate and say horizon is my 0 degree, okay, 0 degree altitude. Let me see, north. That's right. Let me make sure north is directly in the center. Okay, at the center. And the north is the 0 azimuths, right? And then 10 degree, 20 degree, all around, right? From north towards east. Now you have to visualize it a little bit, right? Because it's a 2-dimensional projection. So you're really looking around eastward and westward, and then you see, this is more like, looks like it's 15 degree. 1, 2, 3, 4, 5, 6, 7, 8. No, it's 10 degree, right? So you're moving 10 degrees eastward until you reach east, right? So as you move this way, it's 10 degree grid. And as you move up, it's also 10 degrees upward. And this right here, remember again, this is a 2-dimensional projection. This is really directly on top of you, okay? This is your zenith. Of course, the 2-dimensional projection doesn't show that. So you turn your head directly up. That's this point. It will be easier if I show you. There you go. See, in a sky center view, the 90 degree altitude, right, is directly overhead. Okay, right here. And I said it converge. All the lines converge on zenith, right? Converge on zenith, right here. Now let's go to the other one, which is the equatorial grid. Now this is the celestial grid, okay? This is a celestial grid that is agreed by everyone around the world to be a fixed. It's a fixed grid on the sky, right? It doesn't move with you, right? So imagine you are surrounded, Earth is surrounded by a celestial sphere that is fixed. Okay, the entire sky is a fixed canvas, it's a fixed painting. And we are the one that's rotating. So as the evening goes along, the equatorial grid will actually move because we are actually the one that's moving, right? Just think about that. So let me turn off the horizontal grid just to show you. Yeah, it's not. Yeah, once again, Stellarium is very slow because it's very computational intensive. Okay, and so it is already a little bit different. As of now, we are located in Rockville, and you can see that. I want to point out this is a north celestial pole, and this star right here is Polaris. Okay, and so let me move the time around. Let me move. You can see the grid actually moves, right? Rotates around the north celestial pole, and that's Polaris. Remember, Polaris is that star that doesn't move. And so think of a celestial sphere that is fixed. We are the one that's rotating. So from our point of view, that's what it looks like. However, let me turn on the horizontal view. Okay, the horizontal grid. You can see the horizontal grid does not move because you're the one that is setting up your own horizontal grid with respect to yourself. And of course, it is fixed in your own coordinates, okay, in your own location. it does not move, okay, because you're the one set it up according to your own view. Okay, I think this is the end of the introduction.